Yo, good morning, good morning. Currently in the process of improving the terrain data system, and it works pretty good so far. We can now alter it again. We're pretty much where we were, but with way better backend. But we still have one tiny little problem with it, and it's the initial generation that leads to a little bit of a seam, but only in the X direction. Couldn't get to the bottom of it yesterday. Hopefully we will do today quickly. Yo, what's up, Calvino? Good morning, good morning. The pipeline is quite long for the instantiation. We have a lot of different classes involved in it, so it could be, this could stem from a few different places, but what I think the most crucial part is this one, and that's where we calculate the coordinates, and then we calculate, and we use these coordinates to read a from the noise function. I think we're gonna try generate byte value here. We're gonna generate a byte value that represents the coordinates instead, and we can see, double check that the coordinates are being generated in the correct way. My assumption, or what I think we're seeing here, is that we have some mismatch between the last X value of a patch and the first X value of the neighboring patch. So let's see, but before we do that, I just need to check when we send in these values to this one. We use index as UV offset, UV scale is 1 and noise scale is 10 currently. We're going to change this to 1 as well. Yeah, let's change this one to 1 as well. And then we do this. So when we get to generate byte value here, what we're going to do instead is we're going to calculate coordinates, and then we're going to do this one is 1, this one is 1. And this is, one sec. And this is the patch number in the direction. So, and I think we have 0, 1, 2, 3. So we're gonna do coordinates is equal to coordinates.x is equal to I think this one should go to 0, 1, 2, 3. Now we're actually getting 4. So now we have a value between 0 and 1. So what I want to do then is return byte 0.5 times coordinates dot x And let's do it like this. Coordinates.x plus coordinates.y. So now we have between 0 and 8. No, 0 and 1, so now we have between 0 and 2, so we do 0.5 times this one, and now we do byte. Oops, am I thinking about this correct now? UV between 0 and 3, 0 and 4, divide by 4, so we have between 0 and 1, then we add them together between 0 and 2, 0.5, still 0.0 to 1, and then lastly I want to do times 255. Yeah, let's try this, let's see what we get. Do we not have... This looks perfect. So I'm wondering, do we not have... UV coordinates seem to work out just fine. Or actually... We might have some weird mismatch over here. Yeah, we do. Can I see some pattern here? Or do we have the first one? We have it here. Even though with these calculations, this point and this point should have the same. So for the first one, this one is 0. maybe we should try something else. Let's do... Yo, what's up, Cooler SK? It's the last one doesn't correspond to this one. What the fuck? Let's see. Return u is equal to 0.0 or u is equal to 1.0 or u. Let's just do it like this for now. If so, 0.1, otherwise 0.0, or actually 1, otherwise 0. Okay, don't we get anything? Return 1 and 0. Okay. And this looks all right. This looks all right. Actually, yeah, that's true. Let's do this, or u is equal to 4.0. And then we do... And let's make it a little bit more apparent, so 255. Okay. Cooler SK, that sounds exactly like me right now. Tired as fuck today, but I'm still gonna try and make get some things done. We generate the correct UVs. We change the heights accordingly. So it doesn't seem to be a problem with UVs. Do we have a problem with the noise function? I wonder if it's this. It could definitely be this one, but I wonder why it's only in the X. Fuck it, let me do it like this. Good morning, Geralt. Good morning. I'm starting to think that this might be something with the... so here we have 0, we have a value of 50. Yeah, they are the same. Do we have a difference? No, we don't. So the coordinate is actually correct. Fuck, am I gonna have to test the y coordinate as well. Maybe it's the y that fucks it up. Okay. Okay. Interesting. Very interesting. We should be getting y is equal to 0, 0, 0, 0, 0. No. Or yes. We should. 0, 0, 0, but we don't. Okay. Right. We should get lines very much like we get with x. But in this direction. Why don't we? Okay, so generate byte value. So probably the fault lies within this one. I divided I dots. In fact, do we want to round here? Int divided by int. So pretty much we should be getting 0 here. Zero divided by size x is 0. 1 divided by size x does not result in 0. Really? I find this to be very weird. Mathf dot floor to int. Cast is redundant. This should return an integer. This one is an integer. No, it's a float. Oh. Interesting. So if we do size, I reckon with height, size. Yeah. Don't care too much about this. Is it enough to just have it as one, have it as float? We're gonna have to work around the float value then eventually. Or should we just go with two different, cast it, vector2 int. Or actually we could do it like this. Static. Didn't we have one like this? Round to int. Okay. Floor to int. Okay, let's... So we just do buffer type size dot vector2. I thought vector2 int does not contain a definition of vector2. Fuck it. I guess we can do it like this. We should be able to. Okay, not. What the fuck? It should be, we should be able to do it like this. Size returns vector2 int. We should be able to do dot vector2. Or something like that. How fucking annoying is this? Round to end, we want to go the other way. Do we have anything nice here? Let's just do it like this. Let's see what kind of result we get now. So now we do division between two ints. We should floor it by default. That's more like it. Okay, let's see if we get the correct values then, or if we still have seams. So it all came down to me doing the assumption that we were working with integer values, but we were actually working with a vector 2 that holds floats. So we got float values on division. Do we have a difference in height? Yeah, we do. I don't think we have any seams. Let's try and do terrain data, terrain patch, and then we do 10 times on noise scale. Need to fix this one as well. Okay, I don't think we have any seams anymore. Okay, that's good. Then we can actually do something fun today, I think. Okay, beautiful. Terrain patch, terrain visuals, noise scale. In fact, do we not use terrain base? Okay, let's see here. I think we're going to go through all the changes we have made here. Commit it. I have one cleanup I want to do after that. Commit that. And when we have that on master, we can start extending it. And I think we're going to do it with a so-called activity texture. Basically, I want I haven't really decided exactly how I want my activity texture to look. And when I talk about activity texture, I mean a texture, so much like the height texture for each terrain patch, but the activity texture describes what kind of movement we have on the texture. So if we have like I want to transfer information about the object that occupies points on the terrain. First, we can probably just do it as a binary thing, i.e. We take the bounding box of an object, calculate which vertices it affects, and then we'll send in 1 to those. So pretty much we will have a grid that lights up depending on where our objects are located. Yeah, something like that. I think that's a good first step. But okay, let's clean this up first. And I want to get the grass shader to work with the new data as well. So we're going to do that. But let's see here. We're going to wait with this one. This should be enough here. Base data. Ooh, I'm not so sure. Fuck, I don't think we need these anymore. No, we don't. That's very nice. That's extremely nice, actually. So we don't need UV scale or UV offset. Terrain patch data, we can remove this one and this one. Buffer scale, offset. Yeah, fuck those. Less data to send, not that big of a difference. So we send the buffer and its size. I guess we can do this instead with height. Fuck it, let's do this. size. Okay. Want to get to the bottom of this as well. Garbage collector, disposal, compute buffer. Array, please use compute buffer, release or dispose. What do we have? Terrain data 81. Oh, destroy. I think this one is being called terrain data. Oops. It's been called in terrain patch data in destroy here. This one is being called from terrain base on destroy. Private member is unused. I'm not so sure about that. Let's see if we can get rid of it by doing this then. Compute buffer. What did they want? Release or dispose. Let's see the difference. Compute buffer unity. Release we do have. Let's go for release. Use young. What's up? What's up? Yeah, let's go for a clean release there, and let's see if it complains about it anymore. We have a problem of terrain-based data UV offset 110. Yeah, fuck. Oh, do we use it for the grid? Okay. Yeah, then we might want to be careful. That sucks. Eventually we don't care about the grid. But honestly, I want to see if we might as well just do if it's enough to do this. I think we can correct this without sending anything down to the GPU. We basically just want to offset it 1/2 pixel both in X and Y. I think we should be able to do this, but we compare this one to, let's do float to offset is equal to yes. There we go, I think. Yes. Okay, so we don't need to send in that. We just do we use the width and height of the buffer. This is probably, yeah, we don't care about this stuff other than to draw a nice debug grid currently. So that's okay. Okay. Need to do the same here, so let's do Okay, so debug shader done. These are done. Terrain procedural grass. I just want to make sure that we can draw grass, that we render grass as well. Currently we use wind texture, terrain data texture here to do replace with compute buffers. Do we use these here? And what we're going to do instead is include shader utils terrain data and terrain base data. .hlsl. So eventually this is how we're going to split it up. I think it's the correct, it's a nice way to do it. So grass, for instance, will need foliage. So this could probably, yeah, we're going to need a lot of data for that one as well. So instead of terrain base data here, we will have terrain foliage data. So this one includes that one. So yeah, depending on what data each shader needs, we can include terrain base data, terrain water data, and so on and so on. And we can include multiple of those if we need it. So let's see, terrain data. So here we did it like this previously, sample texture to the LOD, not this one. I just tried some things around. So instead of all of this, we're gonna have something like float4 terrain data is equal to sample, I thought I named it that. Let's see here, get terrain base data. Get terrain base data UV. And that's about it. That's how we get the data. Pretty straightforward. I think this is a pretty clean solution, the more I think about it. Let's see. Terrain data. In here, we're just going to do it as we did. Same here. Terrain data grass. Terrain data UV. We don't have these anymore, so that's good. We can remove them as well. Eventually. Terrain data. Move data reading. Okay, great. Did we have... Okay. Like this. I think this one should be clean now. We're gonna try it real quick. Let's see here, terrain material. I think we can remove some of these. Terrain material, terrain data texture, UV scale. I want to remove these as well eventually. For the water one, but okay. Probably don't want to make the grid disapparent, but what did we change this time around to make it? Yeah, I think previously we did bilinear filtering when we read the grass data, and so you got some nice interpolation between data entry points. Of course, that's something we would like to support here as well. We can't really do it. We don't. That's one of the negative things with going with this solution, but what could help with it, we could we don't want to do bilinear filtering ourselves. It's going to be a mess. That means that we need to read 4 values for each pixel value, basically, and then interpolate between them. But I wonder if we can rely on the interpolation you get between vertices when you do in shaders. So basically, let's draw this real quick. I think we can. I'm pretty sure we can rely on that one. So right now, we actually read terrain data 5 times, 4 times maybe, 3 times I think. In the tessellation shader, I think that's the first time we read terrain data to figure out how much we should tessellate it. We have UVs per vertex, and so for this vertex we take this UV and we read a value. Then in the geometry shader we have tessellated this a bit, so maybe we have something like this in a perfect world, but this is not how we tessellate it, but let's say we do. The UV we interpolate during tessellation, so if this one has UV 0, 0, 0, 1, 1, 0 and 1, 1, this one will get UV 0.5, 0.5. But when we read from the terrain data texture, we take this UV and we match it to a pixel in the data, not a pixel anymore, but a data index, and then we grab it, and we don't get any interpolation or anything like that, and that's why we get the patches. But if we would, in the vertex shader, we read the data for each vertex. So we read terrain data. And then we send it onwards. That means that this one will, if we tell it to, it will interpolate between shader stages, which means that the data we have here will eventually be a weighted data value between the surrounding vertices. I wonder what kind of result we would get with this. And this should work. So if we didn't have tessellation, we didn't have geometry shader and whatnot, we only have vertex shader and fragment shader. So when we render a triangle in the vertex shader, we read the terrain data and then we send it onward to the fragment shader, and we should be getting interpolation for the full triangle, or the data should interpolate between. It depends on how we send it, but I'm thinking, let's see here, HLSL text chord semantics float 4 color. Yeah, we probably want to send it as color. We don't use this one, so we can take this one. We have I think we have a lot to choose between. Can we get? I'm pretty sure color should interpolate between stages, so okay, let's try it. Terrain procedural grass, terrain data. The first time we read it is in hull shader constant. Now we're gonna do it like this. Vertex shader input, we don't want it here, but vertex shader output, let's add float 4 data color 1. Float 4 data color 1. We care about it here. We're gonna do a lot more interpolation calculations, barycentric interpolation, I think, but we will be removing two not texture reads anymore, but 2 data reads. Color, just to make sure we can go with 2 here. I don't know if this one is 0 indexed or not. Geometry shader output to... Okay, and then we just have to follow this one along in the pipeline. So vertex shader, what we want to add here is output.color data is equal to get terrain base data input.uv. Hull here, we just want to make sure that we pass along the correct data, right? Patch id.data is out of bounds, is point out of frustrum, should backface cold, should out. Okay, so down here, terrain data. Here we need to do an interpolate barycentric. So we're going to do get terrain data. Interpolate barycentric. Data. Domain shader. Here we need to do something very similar. One sec. Float 4. Geometry shader, here we want to do the same thing. So instead of doing terrain data read like this, and then we have this to do, which we're currently doing. So remove this. Wonder how this will look. Here we just call it data. Down here we call it terrain data. Whatever. And finally, in fragment, we should be having... we don't need to do anything, so I think we can do... We can just add input dot terrain data here. Yeah, let's try. Yeah, what's up, Brack? What are you doing today? For the last couple of days, we have been redoing the backend terrain data handling, right? We have switched out the dependency of texture 2D to, we have switched it to compute buffers instead. And then we have redone parts of our code to work with that, and we're close to being finished with that. So right now I'm just cleaning up a bit, making everything work as it did. Then we're going to commit it, and then we're going to start experimenting with something I refer to as activity texture. It's pretty much just in each frame we want to store data of how objects in the garden move, so which points of the terrain is occupied by how and if a point in the terrain is occupied by an object and the properties of that object. Hopefully that makes sense. Sam's Might, yo, what's up? How are you doing today? I just managed to buy myself a low-profile mechanical keyboard after thinking about it for a year. Okay, so it sounds like you're doing great. Low Free Flow 84. What do we have here? Low Free Flow 84. It has the Nordic layout as well. Nice. So it's this one we're talking about, right? Black or white? Okay, so everything should be fixed here. Let's see what we have. We have some errors. Unexpected token float 2. Yes. Invalid subscript input. Yeah. There we go. It's better. It's not as blocky, but we don't get any ground color changes. Black one, nice, nice. Looking forward to hearing what you think about it after some time. I've been needing to switch out my keyboard for more than a year. The FPS is jumping quite a bit. Yeah, I've noticed that as well. Honestly, don't know why right now. I'm pretty sure we have some problem with the terrain material. I try to keep my performance good. I do performance checks now and then. Try to keep it above 200 at all times. Previously we could pretty much have a full terrain with covering the grass shader and being close to 200 FPS. I don't even think it's the grass per se. We're gonna take a look at this one. But rather, let's see here. Yeah, it's this. The tessellation. The tessellation doesn't work. We can see it here. We tessellate too much when we don't need to. And the reason for that might be 10100. Yeah, the reason for this, has to be right. We don't need and we don't want to tessellate here, so the reason for this is probably because it's a good catch, it's a great catch. 2 times 49, you're running on your dev rig. I fucking wish, man. I fucking wish. So the tessellation isn't being calculated as it should. I'm thinking it has to do something with, let's see here. Where do we have it? Yeah, here we're tessellating too much. This one, subdivision bounds T. Subdivision bounds X, Y, T. I want to double check one thing. Subdivision bounds 10, 1. $50. $10 to $50. Yeah, in this case, I think it's just dependent on, let's see here, else. We can do something. Yeah, we don't use this one here right now. Fuck, have I committed something I don't want to... Yeah, there we go. We're missing this comparison now. If it's less than 0.4 ground grass colorized bounds, copy change lines. Let's re-add this one. It's this one we want to remove, we want to keep this one. Yeah, so we read the terrain data here, but we didn't use it. So it's basically, if we don't have any grass, don't subdivide. And we subdivide based on some other stuff as well. 200 still. It's okay. Y539, what's up by the way, is grass individual blades or textured quads? It's individual blades currently, but honestly I haven't really decided yet if we're gonna go textured quads. Like, you get a lot of good things when you do textured quads instead. You get a lot of alpha checks instead, but whatever. We could optimize in a whole different way. We could hide 2, or we can put 3, 4 grass blades in one quad. But the main reason I want to do it is because it's going to be so much easier and more performant to do different types of grass. Grass that looks widely different. We could do flowers much easier because we just do a texture map and quads. We'll see about that. Calvin, I'm very interested in SteelSeries Apex Pro TKL. The name of these things. It looks pretty damn nice. Me personally, I'm not like, I haven't really become fond of RGB lighting right now. I guess you can turn it off, or you definitely can. But apart from that, okay, so now we're back to how it looked, except for the fact that we don't color the ground. So I want to check, why the fuck don't we color the ground? We color the ground, let's see here. Ground color. I guess it's this one. Yes, because we don't send the data onwards, so we need to do that. Generate geometry shader output value, generate geometry shader output value. I don't know where we want to put it. Let's put it here. Output dot data is equal to terrain data grass. I don't know if it's that one. We probably want to do this now. Float 4. And then we have terrain data here. Yeah, so let's see. Let's change this one to terrain data. Output data is equal to terrain data. Output.data is equal to terrain data. And then we need to change this one. And that should be it. Y539 problem with textured quads is they look awful up close above. Yeah, I agree with that. There we go. Yeah, so now we should be back to what we have, and we use compute buffers instead of textures, so that's very nice. Grass is done. Did we use terrain data in water? No, we don't. Not yet. So terrain procedural water, this shader will actually use more than one terrain data buffer. It will use the activity buffer and the water buffer, I think. Calvino, I needed the RGB lighting growing up since I played Seas in a completely dark room. It's a very romantic picture you paint. Good thing about RGB is that you can always disable it. Yeah, that's true. Would be extremely weird if you couldn't disable it. Okay, we don't need to change anything in water. We have changed in grass. The bug shader, what do we have here? We don't need these anymore. We don't use them. Terrain data. Okay, good. Let's commit some of this then. What do we have here? Terrain. Texture generator, yes. I want to rename these as well. Haven't I committed these yet? Gradient texture generator, Perlin noise texture generator. Do we use this one? Weather. Ground. This one is extremely old, I think. Or I hope. Do we reference it anywhere? No, we don't. Do we have... no, we don't. Ground. Yes, okay, what I'm gonna do here, we're gonna do some cleanup here as well. Gradient texture generator, we're gonna put this one in here. Or we're gonna create one new. So we have constant data value generator, Perlin noise data value generator. We're gonna have a gradient data value generator. We're going to remove this one, we're going to remove this one. The ones that use these two are going to use these instead. We're going to rename this one texture generator. We're going to remove this one, I think. Let's see here. Yes, we're gonna do this shouldn't take too long. Improve texture generators. I think I want to close this one as well, but yeah, we can probably close this one. Wonder if I wanna improve and rework texture generators into data value generators. Yeah, let's close this issue as well. It shouldn't take too long. So yeah, I think we're gonna make this into an... I always forget virtual abstract. I think we're gonna do it into a virtual class. Virtual class that implements I think we can clean this up a bit. Let's see here. It's virtual C# virtual abstract. Oh yeah, this is how it is in C#. Yes. Abstract has to be implemented by subclasses. Okay. Public abstract class, data value generator. Could we... So we're gonna do public abstract float generate value, and then we're gonna do public byte generate value byte float u float v return generate value uv times 255. Okay. Like this is, we're gonna add a couple of other methods here as well eventually. There we go. And then I wonder, we're gonna have, let's see here, texture generator, color pixels. Data value generator, we're gonna have generate texture content, texture params. Yep, we don't care about this one here. Return this is true. We're not gonna do this in real time anymore, so we might as well do int channel index. And then we do channel index is equal to generate value UV. Okay, so that's texture generator we now have in data value generator. I'm gonna do this one. Texture generator delete. Fuck, let's move these up here as well. Perlin noise texture generator. So instead of all this shit, hopefully we don't use this one anywhere. Perlin noise texture generator we can delete. Gradient texture generator. I want to implement this one as a data value generator instead. The problem being, how did I solve this previously? Gradient evaluate. Yes, we use a gradient here. We can probably do it as this. Let's see here. Constant. Yeah, let's duplicate this one. Gradient data value generator. Gradient. Right now we only do gradient in the X direction, so I'm not going to care about seeing if it's X or Y decided. Okay, what do we need? So we just do it like this. We want to interpolate, generate value. Do we have any? Oh yeah, we're gonna do gradient data value generator, and we're gonna send in a gradient, which makes me think this one probably has a lot of these functionalities, but we would like to easily convert it into a texture. So yeah, let's do it like this. And then generate value is going to be as easy as doing UV evaluate T. Yeah, we're just going to do return gradient dot evaluate U. Gradient returns a color, however. We could do it as this, or we could do probably going to change this eventually, so let's just go with something quick now. Let's do A, but probably want to let's do it like this for now. Okay, so there we have it. We convert it to texture by using this, or we fill up a texture value rather. Let's see if we can eventually add some more nice functions here. So, but for now, let's remove gradient texture generator as well. Let's see if these were used somewhere and how we can change it. Is this true? Or do we have some issue with compilation? I'm having a hard time. Gradient data value generator. Oh yeah, I fucked up. When we renamed it, there we go. Okay, let's just fix these real quick. Data value generator does not exist. That's true, because now it's just data value generator. Generate byte value. Generate value byte. Generate byte value. Yeah. Ground we don't use anymore, so I don't really care about that one. I'm pretty sure. Terrain patch data generate, we send in a data value generator instead. And weather, yes, okay. This would be very nice to be able to do. Let's just change this to offset, UV scale, noise scale. Periodic true. Like this, and then we want to force generate texture. We're not going to do it like that this time around. Instead, we're going to do data value generator. One sec, can we do it like this? Perlin noise, private. Fuck, let's try and do it like this instead. Can we do serializable? Okay, we need funk. Serializable weather serialize field. Let's try and do yeah, we need those to work. I want to know if I can do it like this. A little bit uncertain how it works with abstract classes and stuff like that. But we will test it eventually. What I would also like to have is in data value, I would like to have public void generate texture content. Here we do texture generate as texture, and vector 2. Let's take a look soon. So here we do texture to D, texture is equal to new, texture to D with height. I think we're just gonna go with default first of all. So we have the texture, and then we do generate texture content, texture, return texture. Oh, channel index as well. Oof, that's true. We're gonna do it in a very unoptimized way this time around. Isn't this one? Oh, it's not here. We do it like this. Int, sorry. Channel indices, and then we do for each. Like this, and then we do no, fuck, I'm not params C#, isn't it? Oh yeah. 0, 1, 2, 3. And then we can remove this. So then we can have wind data generator. Fuck yeah, let's do it like let's do data value generator. do want to see in width and height. We should have a default width and height. I am Harley-O, thank you for the follow, appreciate it. Fuck, how do I want to do this? I think we just want to do it like this. Private texture, we do it lazily, and we do if texture is equal to, it's not equal to, and texture dot width is equal to width, and texture dot height is equal to height. I just want to try and avoid return texture. I just want to try and avoid so generate as texture width and height. If we already have a texture and the width is the same and the height is the same, just return whatever we have. Otherwise, do this. I'm Harley-O. How many weeks or months have you been working on this game for? Try years, man. Okay, this should work, and then we can do in weather, we can do... I want to try to see if we can get around this one, but wind data generator... And here we do texture... No. Generate texture content. What I'm wondering, yeah, let's do it here. Diox, what's up? How's the workflow? Just heard you've been working on it for years. I feel you. I'm 5 years deep on my project. Let's see. Initially I wasn't that consistent, to be honest with you. Previously to starting this project, 3 years ago now, I think, I had done some smaller game projects, and yeah, it's fun releasing games, but I felt ready to do that dream project, you know, relatable. So I started working on it. Wasn't that consistent, had a hard time figuring out schedule and stuff like that. So it was on and off, but then starting at the end of last year, actually, I started to try and get disciplined with it, and at the start of this year, the 19th of January, I think, I pretty much told myself that I should stream. I should work on this game at least for a couple of at least for like 3 hours every weekday and stream it. And since then, it's been pretty consistent and pretty good. If we're talking more about the workflow, I've been also having, like, usually how you do games, right, is you implement game logic and stuff like that. You use placeholder art and whatever, and just try like to get a pretty good end product so you can see if it's fun or not. I haven't really done it that way, to say the least. I've been doing game logic and visuals in parallel, but that's just how I like to work. Hope that answers the question somewhat, and good luck with your project. Okay, property name we still need to have here. That sucks, but I think we're gonna do wind texture size, serialize field, wind texture name. I think we can do it like this. As for the name, what do we have? We have wind texture. Beautiful. So we do it like this. We don't need this one anymore. Generate as texture. We instantiate it. I think we want to do it like this. Oh yeah, of course we need I feel you, it's been a rough road, but every little milestone I hit, it feels good and motivates me to keep going. Yes, indeed, I agree 100%. I also, so like previously, I tried to release some devlogs as well. I'm gonna try and pick that up next year. And that also helps a lot, actually. Almost feels like a mini release every time you release a devlog. Okay, so what we want to do here is set material texture. I don't like this. We're gonna do nah, I like this. Okay. Debug material set texture. Okay, we're back. Let's see, environment, weather. Yeah, it doesn't really work. Wind texture size, wind scale. We don't have. So weather, data value generator serialized field. It could be. This one is serializable. We might need to put it. Can we put it here? Let's do it like this. Abstract class, yeah, I don't know. Okay, we can't do it like that. Diox, I see you're a Unity guy. I'm a UE5 guy myself. Yeah, picked up Unity first and just stuck with it pretty much. Been thinking about switching, but you know, I like the direction Unity is going in now, and I know it quite well, so yeah, probably gonna stay a Unity guy. Okay, so the problem here is that we can't do serialized field data value generator like this. We're gonna have to add some settings here, but that's okay. We're just gonna do wind scale like this and we're done. One more thing actually. Wind texture size, we already have it. That's good. I don't even remember what we had for our wind texture. It wasn't the best one anyway. Weather, wind texture size, let's go with 512, and wind scale 10. Let's see if we get any runtime errors. Okay, no errors at least. And we have some wind. I wonder if it's... Yeah, might wanna make that scale a little bit smaller eventually. Make it periodic as well. We need to, yeah. A periodic is true. We should be having a good one here. Okay, but that's nice. We don't have texture generators anymore. We have data value generators which can return textures. I think that's a better way to do it. And when I look at terrain data, how we generate it here, yeah, we want to do it like this. Okay, that's good. So I want to commit this as well. I think we're going to start by, we're going to break master a tiny bit, by committing this and resolving this issue. Derek, so you finished the rework? Hell yeah, we did. Everything works as it did. It's a little bit cleaner. It's a little bit quicker. It's beautiful. Maybe possibly we will begin the activity texture today a tiny bit, but yeah. Yeah, so let's commit these real quick, finish or resolve this issue. Just gotta make sure that we let's see here. MISC generators, spawners, temps tools. Okay, so what do we have here? We have a lot of new files and a lot of renames and a lot of deletes. That's very good. Generalize texture generators, generalize and improve texture generators into data value generators. Resolves 86. Briefcase, what engine? Unity. Okay, closed. Nice. Derek, hell yeah, indeed. So can you explain for me one more time what the activity texture is? Sounds interesting. It's probably the wrong name for the wrong texture, but it's pretty... It's pretty standard to have this in games where you want characters and objects to affect the environment in certain ways. So our activity texture, or what I refer to as an activity texture, it's basically just going to be a mapping. So for each point in the terrain, we're going to have data regarding the object that occupies that point. So initially we're going to do it in a very rough and very binary way. So if we say that this is the activity texture, we're pretty much going to add a value to the points affected by our character object. So it might look a little bit like this, probably 0 here and 0 here. So if he's standing on this point, we will have some values on that point describing the object. So if we run, those data points are going to light up, and given some time, these ones are going to remove. That's basically about it. We're going to use it for This one, partly. So water edge details foam when objects enter and exit the water when they move in water. We're going to use it for the grass, to bend grass depending on objects standing on it, running through it, stuff like that. Eventually I would like to have weather effects like snow and stuff like that, so we're going to have it for that. But it's not only for visuals, we're also going to utilize it for AI, I think. So when we do pathfinding and stuff like that. Still not 100% sold on it, but I think it might. It's all gonna come down to how quick we can transfer data in real time from the CPU to the GPU, but I think it should be okay. Hope that explains it a bit. What more issues do we have? Rework terrain data underlying systems. I'm gonna commit shaders, shader utils terrain data here. We're gonna commit terrain data packing and terrain base data for now. Okay. And this is related to this one. Okay. These three we're gonna commit in the big rework commit, so let's add those. Git add shaders, environment shaders. I want to add, yeah, we're gonna add all of this. Let's see. Am I okay with everything here? Terrain base, what do we have? Terrain data looks good. Terrain data type. Yeah, we changed these things, added these. Okay, that's good. Terrain patch. Yes. This one I eventually want to merge into terrain patch as well. We're gonna do that right after this commit. Terrain patch mesh. Did we change anything here? Yeah, we removed that. Okay, yeah, that's good. We removed this one. Terrain point. Yeah, we just did this. Terrain point I would like to remove as well eventually. We might be able to... Best case, we can remove, or we can merge terrain patch data into terrain patch, and we can merge, and we can remove terrain point as well. Best case, best case. Okay, let's commit all this. So what is it? Git add, is it everything in environment, I think? So we have Terraform brush we changed as well, but we just added, fuck, we can't see diff now on terrain data. Yeah, good changes. And then we have debug terrain as well. I think that's it. We want to add the materials as well. Materials, environment materials. Oh, fuck it. For some reason I have environment materials. Okay. Okay, I think I'm done. Let's commit this. One sec before I commit this. Can we resolve this one? Rework terrain data, simplify terrain data type methods. Terrain data type. Fuck yeah. Buffer name. As color. Yeah, I want to leave this one, I think. Is mesh dependent. Color right mask. Buffer index, data index, yes. Set, however, I think we can remove this one. Set int and alter. Yeah, we can. Done. Make sure the conversion to GPU performs only when absolutely necessary. Remove need off. Okay, so I want to leave this open still because I want to do this. I want to research this. We still have these ideas I want to explore. Let's see here. Merge terrain patch data into terrain patch if possible. Okay, but let's commit this. Git commit rework terrain data and underlying systems. $539 insertions and $565 deletions. Oh, even less code. Nice. Okay, beautiful. What I'm going to start with is I'm going to double check. We can probably do this one really easy. So terrain patch or terrain patch data, it's pretty much just an extra pretty useless layer between terrain patch and terrain data. We have this, and then we have a lot of methods to work with that one. We have generate data, generate values, apply data, set data in material. Then data blit. Yeah, fuck this. We're just gonna merge this with terrain patch. So terrain patch. Yeah, we are. Public, however. Do I want to be able to? Yeah, maybe. We're gonna change these to yeah, it's actually this one we want, so let's change this one to byte value. I don't know about that name though. Data value, data byte value. For type at this index, and then we have float data float value, terrain data type. Here we do a height remap though, that's not entirely correct. This is more like height, but then we don't need this one. Height range remap 0255. Terrain data destroy. Instead we're gonna do for each okay, that's good. Then we do terrain data information string. Information string. Data byte value. Public string data string. Yeah, we also want public float data float value, yes. Terrain data type. And I would do data, fuck do we want to do? No, we don't need to do inverse slurp. We can just do data byte value type x, y divided by 255.0. Double the float. F. Data string. Here we just return data Yeah, we want to do this as well. Yeah, maybe. Type as string, and here we do data float value, type x, y. Terrain data, set the data in material. I think we can be a little bit cleaner here. Terrain patch, data, set data in material. We check this, and then we do for each. We only do this once. Set buffer, apply data. Fuck, we want to do it on material copy as well. Terrain data, here we instantiate it, resolution. I wonder, resolution with height, we use it here. And then we instantiate data as well. Not return. Can we do it like, yeah, buffer dot height dot generate values. generator. Alter terrain data blit. This is hopefully the last one. Where do we have it? Alter terrain data blit. This one, yeah, let's go. Remap between 0 and height range. Remap. Yeah, probably need to do this stuff, but I wonder, could we just do terrain data type? Couldn't we just do get terrain patch? We should be able to clean this up by utilizing this one, I think. Height remap 0255. Height. So current. Oh, yeah. Never mind. This we could probably clean this up quite a bit as well. So if we take a look at the data values, we have we store them as bytes, so value between 0 and 255. We have the option to normalize them to a float value, or to transform them to a float value between 0 and 1. And then we have an additional transform that should be done in certain cases. So think about it like the byte value 0 to 255, it's the local value as a byte. The float value between 0 and 1 is the local value. And then we also want to have like a world value of it. So we want to transform it to world space. But we don't do this with most of the data we're storing. The 0 to 1 local range is more than enough. But for instance, if we want to alter the mesh, we want to have the full range for height. So we store the height value between 0 and 1, but then we want to transform it to the actual value. And that's what we do here. We want to do the same with water. The question is, are those going to be different from each other? Maybe. So it's basically height range here. So for now we might as well do data byte value, data float value, and data string. Real value, I don't know. So basically what I want to do here is so it's not tied to height range. But let's see here. Height range remap 0 to 55, data byte value. And type. Something like this. Baptist, what's up, what's up? So data real value. So what we can do instead is current is easy to change. We just change it to data real value terrain data type. Here we just send in type and ij. And let's see what we do with up. It should be get terrain patch dot data real value type like this. Get the correct terrain patch, get the real value data of this type, yeah. So what is it? Current and up is already down, so we can do get terrain patch. Then we remove these, and then we change these ones to real value. Or okay. That's pretty much it. Okay, so now we don't have any issues in terrain patch anymore. We added a few getters, changed, replace one line with 12. I think this is good. So tomorrow I'm just gonna fix the last thing in terrain base, terrain point, commit that, and then we can start with the activity texture. Nice. Slowly but surely this backend is getting cleaner and nicer and quicker, so I'm happy. But yes, I gotta run now, so thank you so much for watching, everybody. Appreciate it. Have a great rest of the day.